Hello guys, and welcome to our fifth lecture. In this lecture we'll be talking about lists and how to define lists, how to process variable length sequences, because as I mentioned, arrays are very similar to lists. Actually, behind the scenes, lists are basically arrays, but there's some very important properties that we should have in mind, and they're easier to use. They have a lot of built-in methods. For example, list, you can sort a list with only one method. You can also iterate through a list easily, and so on. We're gonna see right now. So what are we going to be talking in this lecture is how we defined and initialize lists. Again, if you have done all your exercises about the arrays, lists are gonna be very intuitive and very easy for you, and that's why I'm gonna have in mind and that you already know what arrays are, and I'm just gonna point out the differences between lists and arrays, and I'm gonna show some different ways of accessing and adding elements inside a list that you can do apart from assigning variables to arrays, right? We're gonna speak about how to read lists from the console line, how to print them, and last but not least, we're gonna see how we sort lists and arrays, and we're gonna see that we're gonna understand that using lists is really way easier than arrays. Okay guys, let's get going. Okay guys, so let's see what are lists exactly and how do they differ from array. As I've shown you, lists are on top of arrays. What I mean is they're data structures. They also store elements like arrays, but they have a bit of differences that ease us in using lists rather than arrays. So they hold list of elements like an array, but they have a variable length. So whenever you define a list, you can just define a list without a length, without a predefined length. So you can increase the length in your program dynamically. We have several methods for manipulation. Count, list.count is shows you the number of elements. It's actually the same as in the array.length. I don't know what is the difference. Maybe they have changed the word, just the keyword, so you don't mistake it with array. And so what do we have? We have add, which adds an element to the list at the end of the list. We have remove, and inside the remove method we put the value we would like to remove. I'm gonna show it in a demo. And it returns true if it finds the element and removes it. It returns false if the element is not found. Remove add is actually removes an element at a given index. We have also insert. Insert. How does insert differ from add? As we can see here, we have add and insert. So add appends to the end of the list. If we have, for example, if we have one array, right? One array list, yeah. And here are the index 0, 1, 2, 3, 4, 5. And all of those here are some values, 4, 7, and so on. Here we have 10. If we use add will add to the end of the list. It will create one more cell and add to the end of the list. Insert, here we provide the index at which we would like to insert the element. For example, if we choose index 0, it will add at index 0 and it will override this variable, right? So this is basically the difference between add and insert. Contains is actually a really nice built-in method that checks if the list contains a particular value. It's actually the same as we were doing in the array. It goes like a for cycle and checks if we have the containing value. So it's very easy. As I've shown you, we have a lot of built-in methods inside the list data structure that we don't have in an array, but behind the scenes, list is actually an array. I'm gonna show you after that how does the compiler interprets list. Also, we have one more built-in method. We have a lot of them, but those are like the fundamental ones, and the ones that we would like to use lists. We will be using only list when you have to choose between list and array. We have also sort. Sort the array in an ascending order. What does that mean? If you're going to be storing integers, we know how to sort integers in ascending order, right? 1, 2, 3, 4, 5, and so on. Strings as well. It will sort all the strings in a lexicographical, alphabetical order, but you can't, for example, sort objects that the compiler doesn't know how to compare them. For example, if you want to sort cats, we don't know how do we want to sort those cats, by weight, by name, by color of their fur, or so. Sorting sorts the array in the context of string and integer. It works fine. If it becomes a bit more complicated when you want to sort objects, because we have to explicitly state by which field you would like to sort those objects, by age, by name, or something like that. So this is how we add an element inside the list. As I've shown you, when we create a list, it's not like the array. We don't create a data structure with a predefined length. It's just 0, right? For us, it's just 0. So when we want to add a value, an element inside the list, it just goes on top of the list. As you can see, add, and the count here, and the count increments with every add, right? So also we have remove, and remove returns true if we find the element. And for example, if we want to remove an element that is not at the end of the list, again, this is fine for that. So if we want to remove 10, as you can see, we remove 10, and the count becomes 2, and all the elements, they got shifted on that place. So right now here, 2 was at index, this is index 0, 1, and 2, right? And then when we remove the element 10, 2 becomes at index 1, right? We have index 0, we have index 0, we have index 1 here, right? Also, we have insert at given position. We can insert, for example, if we want to insert at index, if we want to insert at index 1, no problem. We can insert it just straight away. And let me show you how we define list. So a list list is like a class. This class is contained in the system.collections.generic, and we can see actually this class list, and it's a bit more different than an array. Let's just resemble how do we define the arrays. Int array equals new int, and here we should define the length, right? How we define list? Inside those rectangular brackets, they are not curly, they're rectangular, we should define the type of element a list will hold, because again, lists are based on arrays and they hold only one type of variable, right? So here we have to type int list equals new list. That's it. So you have to learn it like that. Again, how do we can also here add int list dot add three, and we can do some more 5, 6, 7, right? Like that. That's actually how do we initialize list? How do we add? Let's print it out. String dot join int list. And let's see what's gonna get printed. You can see 3, 5, 6, 7. So if we want to add 4 here, we have to insert at index 1, we have to insert 4. So here so as you can see here, we have at which index we have two input variables, index and item, right? So at index 1, we would like to insert number 4, right? And it is the same thing as just doing like that. Our array will look like 3, 4, 5, 6, 7, right? Let's see. 3, 4, 5, 6, 7, right? So if you want to remove a value, int list dot remove to remove number 3. Still we can do that. Oops, sorry. Yeah, still we can do that. And yeah, that's basically the fundamentals of using lists. In the next lecture, we'll just have some exercises. We're gonna see how to read from the console and so on. So see you in the next lecture, guys. Thank you. Okay, guys, in our next mini lecture, we're gonna see how to read lists from the console. Again, it's the same idea as reading arrays. We just use different methods. We use .add, list.add, and we add the value, we parse the value from the console line. So everything, if you have understood how arrays work, this is going to be not something new for you, okay? So please make sure you have made all your exercises in the array section, because they're fundamental, and if you don't understand at least a bit how arrays work, it will be a bit hard for you to understand how lists work, because they're based on arrays. They're like extension of arrays, right? And they're made because to ease programmers, right? So reading list from the console, we have here a use case scenario. So first we read the array length from the console, and not because we have to define it, the array length, but we have to create a for loop with this length in order to get every element from the console line. As you can see, create a list of given size n and read its elements. As you can see here, we have from 0 to n, and we add to the list, right? We add to the list. It's something very easy. We can even do it here. So again, if this is too long, we can always write var, right? And what we have var n equals in.parse. We should read from the console line the length of the array, right? And then we initialize the array and create a for loop from I to n, and with each iteration we should add list.add int.parse console.readline, right? And that should be it. And we can write we can print the whole list. Print.join. Okay, let's print it with comma delimiter, and then we pass the list. As you can see, list behaves the same way as an array. We just, for example, what if we want to add here? We have stated that we want array of size n, right? What we want to have? What if we want to add one more here? Int list dot add 1000, let's say. No problem, right? We don't predefine the length. So this is something that is very very easy to use. And yeah, let's see how this program works. So we have to say, okay, that's 5, and then 1 2 3 4 5. Then as you can see, the list 1 2 3 4 5, right? So again, very easy program. Let me show you what the list class looks like. As you can see, it's in the namespace system collection generic. So it's just a class. We have a very big documentation, so you can read it here. It represents strongly typed list of objects that can be accessed by indexed. And the most important things, it provides some methods to search, sort, manipulate lists that we don't have to write from scratch. If you're using arrays, as you have seen, even if you want to find a number inside this array, we have to create a for loop, right? But here we have dot contains. Let's see, can we find it? we have it here, right? Determines whether an element is in the system collection. Returns true if item is found in the system collection, otherwise it returns false. And we have everything, like find all, retrieves all the elements that match the condition specified by the specific predicate. It can return, for example, all numbers equal to 2, or all odd numbers, or something like that. So as you can see, we have a lot of different built-in methods, and that's why arrays are not used, but the list class is made to ease programmers in order to write everything from scratch, sorting and manipulation of big collections of elements of any type. So how do we read arrays or array values from a single line? Again, it's very intuitive, but we have only one keyword that we have to add is .toList, because until here we have a collection. It will split everything in a predefined array, right? In just a simple string array. And when we add the .toList method, it will actually know and convert this array into a list. And then we can use .add and so on. Yeah. So how do we print lists? Let's try this. So we're going to be having list string, and then console.readLine .split, and then if you just leave it that way, you're gonna see what it will tell us. Splits a string into cannot implicitly convert type string to list string, right? And that's why we need this method. It will convert it, right, to list. We don't have it, right? Yeah, we need system.link. Then we have the .toList, right? Okay. And then what we had to do is okay, yeah. So right now we have a list of strings, right? And we want a list of integers. So we will create a new list of integers. So this is string list, and we should create a new list of integers, new list int, and then we will go through the string list dot count, right? And then we will do int list dot add yeah, I haven't shown you that we can still access variables by index the same way as we have been accessing it in the array. So actually here, what are we going to be doing is we will add the string in.parse, and then inside this we'll string list at index I, right? And this should do the work, right? As you can see. So yeah, we need the brackets here because it's an object, and we pass an empty constructor. As you can see here, you can pass here a capacity. You can use it as an array if you know what length, how many elements you're going to be storing. It's good to give the capacity, because what happens behind the scenes is actually we are having, when you make a list integer equals new list integer. If we pass this, what does the compiler does is, what does the compiler do is it creates an array, an integer array of size 16. That's by default. It creates an integer array of size 16. So when we start filling this array, it starts from here, we fill the array, and when we want to add one more element, it gets this array, creates an array double the size, right? Creates an array of size 32, adds this array here, and then we have 16 more elements to add. When we fill this array with elements again, it again creates an array double the size of this, which will be 64, copies this array here, and so on and so on. So what does that mean is actually the size of the array behind the scenes grows exponentially when we keep adding elements and elements. If you're going to be adding 100 elements and 200, this is completely fine, but your collection may have 10 millions of elements, right? I'm just showing you how this works behind the scenes, because sometimes you should know it when you are creating a system architecture, deciding what data structures to use. Sometimes it's better to predefine if you know how many elements you're going to be using. Because, for example, if you're going to be using 17 elements, why having an array of 32 than having an array of 17, right? And yeah, actually that's it. I mean, this is how lists work behind the scenes. It's just a simple array. So how do we print all lists of elements? We can use a for loop. Yeah, so that's actually the basic of how to print an array. You can always use string.join, right? It's for me, string.join is enough. This is the basic way of printing an array. You have to go through all of the elements, but actually string.join does that for you. Does the for loop for you, goes through each value and so on. So if you can do something in one line of code and it's very intuitive, I mean, it's just printing an array on the console. It's not just a very complex algorithm to do. you can just do it that way. Yeah, so actually this is it's straightforward. I mean, it's the same as arrays. I'm gonna repeat myself. Please do the exercises for arrays, because otherwise strings are going lists are going to be a bit complex for you. So what I have missed to show you, we can remove as well something. The big difference between arrays and lists is that we can remove values, right? Wherever in list we can't remove values, we can only just set them different. We can't remove elements. We can just set the elements to different values and so on. So that's the big difference. And we have a lot of built-in methods, as you can see here. If we are using the int list dot, you can see how many we have: min, max, order by descending, remove all, remove at, remove range, reverse. We can reverse a string. We can reverse the list with just only one command. If you remember, reverse an array of this exercise. Reverse an array of characters or array of strings. I don't remember. Is we can do it here with only one line. We just read the whole. Let's do it. Yeah. This is something very interesting. So we're going to be inputting something like this in the console line: A, B, C, D, E, F, and then we want to print it in a reverse order, right? So what we can do is, yeah, we read it, space separated, okay. And then we just do string list dot reverse, and then we print it. Okay, let's see: A, B, C, D, E, E, D, C, B, A. As you can see, only one line of code. As you remembered, with arrays, we had to go for loop with the for loop, and then get the first, the first and the reverse index, and then change them, and something like that, which is very, very complex. Here we use only string.reverse, and it reverses. What we can do is, actually, we can do is dot sort. It can sort it in an ascending order, right? String list dot sort, right? And if you are doing, let's say, KJA and it sorts the array. What in an alphabetical order? What if we want the other way around, right? We just simply do string sort that string list reverse, right? Then we have NM A B NM A B O divs S V Q. You can see it's in a reverse order: A C D M N O P Q S Z, right? So very easy, very intuitive, with only using one line. We have a lot of built-in methods, so please go ahead, try some try some different computations. Even if you want, go ahead and do the exercises for arrays, but do them with lists. It's just to see how what more easier it is with doing it with lists. And that's why I'm telling you, if you know, if you have done all the exercises with arrays, they're more complex with lists, because with lists, for all the computations, and you have functions, you have built-in functions. So sorting, reversing, deleting, removing, inserting at some index, and so on, you have this. So yeah, please go ahead and try it yourself. This is the best way to exercise list and understand list. This is the next step into stepping into a real programming environment. You have to know what list is and how to use list, and you have to know at least the basic methods of manipulation of this list. So adding, inserting, removing. If you can just say if remove this, if you don't find it, it means that remove will return false or something like that. You have to use this feature as well. Remove, add, insert. You have to know what everything does. So add adds at the end of the list. Insert at the given index. So you have two inputs. You have an index and an element, right? The next one is remove, and you have remove add. Also, there are a lot of other built-in features that you can find them yourself, but those are the basic features. You have also sort, you have also reverse, which are very, very important and very useful to use. Okay guys, so see you in the next lecture. Please try all the basic methods used for manipulating lists, and yeah, please do it yourself. Try to play a bit with lists. Yeah. Bye guys, thank you. Okay guys, so let's see now how do we sort lists and arrays, which is actually, you know, same thing. I'm gonna again repeat myself. I maybe sound a little bit annoying because I've shown you in the previous lecture how to sort them, but I have to show you some solutions here. So how do we sort a list? Sorting means to reorder the elements incrementally. It means to sort them in an ascending order, right? So in the context of numbers, it's intuitive, right? From 1 to infinity, right? In the context of string, it will be in a lexicographical order, in alphabetical order. In the context of like a cat, we don't know that. I mean, we have, it's a bit, we have another object which is a comparator. This is an object that goes through the list, through the array of strings or something like that, and knows how to compare them. But if we want to compare cats, and this is an object, a class we have created, the comparator, we have to create a comparator instance. So we have to say, okay, we have cats, compare those cats by name, or by their weight, or by their fur, or compare them by fur and by weight, or something like that. Like, first compare them by name, then by weight, and name is priority 1, but this is something very complex. You're gonna learn this in the process of coding, and whenever you need it, you're just gonna go and see how some real life examples, and you're gonna get used to it. But for now, you have to know how to sort and how to sort primitive types, like how to sort integer and string. String behaves like a primitive type, but it's not. As you know, string is just an it's an array of characters, right? If I haven't shown you that, string is literally an array of characters. You can even string test equals soft uni, and we can even print like the first letter, right? And it is gonna give us S, right? So you can see there. So actually string it behaves like a primitive variable, but it's just array of characters, right? This is something interesting to know, how variables behave and what are those variables. It's also very crucial. So as you can see, list of the items should be comparable, like number, string, dates. If we are trying to compare cats, as I told you, or dogs, or an object that we have created, or that is something complex, we have to define how we would like to compare this. So I'm not gonna go into details about those comparators and so on, and we're just gonna start with the simple comparable elements like numbers and strings, right? So I've shown you in the previous lecture how to sort them, but let's do it again. Let's have list a string, strings, string list equals new string or new list. Also, same as array, we can predefine the containing variables, and also after that we can still add some more items. When on the other side, if we were about to using arrays, we weren't being able to do that. We can't just we can't just start the array with 5 variables and then add 5 more, right? So here we are gonna be having some names. Annie, oops, sorry, Annie, George, ZZ is because it's with Z, Nakov, my name, Ivan, Nikolai, and so on. So we can stop until here. So how do we sort the array? Again, very, very easy. We just type name of the array dot sort, right? And then what we have to do next, we can print on one line with string dot join. No, how do they print that? Yeah, they print it with comma, and we should show the collection we would like to print, and then string list, we can reverse string list dot reverse. Again, we're gonna just copy that. So what we did here is, initially we created the list, right? Then we sorted it. We're gonna print the sorted list, and then we're gonna reverse it in the other way around, and we're gonna print it again, right? we're gonna print it again here. So both here, both lists will be different, right? So let's see what we have. You can see the first one is Annie, George, Ivan, Nakov, Nikolai, Simon, and Zizi, and the other is reversed. This one, but reversed. Okay. Yeah, here in the example shows in a reverse order we have to use first sort, then reverse, and this is descending order, because sort by default sorts in natural ascending order from smaller to bigger, right? If you want to make it the other way around, we sort it in ascending order, then just reverse the whole array the other way around, and we're gonna get. So we have to read, we have a problem right now that we have to solve. So we have to read a list of decimal numbers and sort them, right? So actually what we have to do is just read the input from the console line, right? And then we should add this in a list of doubles, sort them, and then print them, right? Let's do it. So we're going to be having a string array that is going to be our input in console.read line split by white space list of doubles, doubles list, new list, and then right now here we can, right now here we have a string of doubles that we have to parse them. So actually what we can do is create a for each loop double in input. So for each element in input, so for each double, we are going to be assigning double list dot add double dot parse double. Okay, not double, but item. Let's say item. Yeah, because double is a keyword. Yeah, you can't use keywords. The compiler doesn't know is that the variable or it's the double keyword for a variable for a double fold precision, right? So, and right now we call double list dot sort. Oops. We should call double list dot sort, and then we should print it double list. Okay, let's see it. 2.4, 1.2, 3, 5.6, 10.3, minus 1.3, We have a handles exception. Let's see. I haven't expected that. Input string. So it's okay to make mistakes, right? But we need to analyze this mistake and not make them the other time. So let's see. It's at line 17. At line 17, we can't parse this item. What I think is it shouldn't be let's see if it's with dots or with commas. It can't parse the string item. It can't parse it to a double. It means that it can't interpret the double, right? So let's see again. 1, 3, 4. Yeah. So the problem is that the program expects the string, in order to convert strings to double, the floating point, the decimal point, it expects it to be not a point but a comma, and that's why it has given us an error, right? So let's see, 8273. Let's make 8273 2378, right? Yeah, easy peasy, right? 1 minus 0.5. This is interesting. Let's see. 1 minus 0.5. 0.51. Okay. So our program is working. Again, try to play a bit with some doubles and lists, and see you guys in the next lecture. Bye. Hey everyone, let's see one exercise from our in-class lab, and I'm gonna do only 2 exercises for you, and the rest you have to do it by your own. And even that we're gonna discuss it here and see. So we have to read the list of integers and print all square numbers in the list in descending order. So let's do that, right? So let's just see what are we going to be having from the console line. We're going to be having 3, 16, 4, 5, 6, 8, and 9. 3, 16, 4, 5, 6, 8, and 9, right? And the output, 3, 16, not 17. The output has to be in descending order, 16, 9, and 4. 16, 9, and 4, right? This has to be the output. So initially we should be having one variable. Let's say we can even have an int array, right? Integer array, which will be the input. The read line. Yeah, we can. I don't know if I have to show it this with the link queue to select and to convert it straightforward to. Okay, let's just do it the way we know, right? We're gonna have a string array of inputs. Then we're going to be having we're going to read from the console line the input, split it by a white space, right? Then we need to have one list of integers that will store our result. A new list of integers, right? And then what are we going to be doing now? We're gonna create a for loop. We're gonna create a for loop from 0. We want to go through this string array from 0 to input.length, and we're gonna get, so we're gonna have one variable which is the number, which is int dot parse input I. This variable is going to be integer, and then we have to check if this number is square root. How we can check that? We can create another variable which is square root, and we can use the math.sqrt from number, right? And so here we have two variants. So actually, as you can see, this is of type double, because the square root may be not an even square root. For example, square root of 16 is 4, right? But square root of 13 is not 4. Let's see calculator. 13 square root, you can see it's 3.605, something like that, right? So in our case we'll be having 3. So our first number will be 3 square root. We'll be having 1.7373, something like that. So we want to check if we have a whole integer. If we have a whole integer, it means we have a square of some other integer, right? If we have, for example, 16, it will be 4, so this is good. So we want to check if the square root equals integer of square root. What does that mean? It means that if here the square root is, for example, 4, here the integer will be 4, right? And 4 will be equal to 4, right? Because when we cast double to integer, we only take the number before the decimal point. For example, here, when we have square root of 3, we will be having here, we'll be having 1.7, something like that, right? I don't remember the other thing. And here, our comparison will be 1.743, something like that. Is it equal to 1? Because when we cast 1.743 here into integer, it will take only 1, right? It will be 1. So we want here this number to be without a decimal place. So that's how we compare it. And if this is the case, we just add this to the result. Result dot add. Oops, result.add number. Then after adding the number into the result, we have in the list in descending order. So in descending order, it means that after the for loop, after we have gone through each element of the array, what we have to do is we have to create result dot sort and then result dot reverse, right? This was the descending order, right? Because sort sorts in a natural order, reverse the whole array. And then we print it. Let's see how do they want to print it. Just space separated. Okay. Console write line string dot join result. Okay. Let's copy now. Can we copy those values? Sure, we can. Copy. Run the program and paste them, and you can see 16, 9, 4, right? We can even test it in Judge. I've shown you how to test in Judge, so you can go ahead and test the solution. And basically that's the real thing about the square numbers problem. I think in your lab this is your 6th exercise, so we have done it in class, and we are gonna do one more exercise, and the rest you have to do it by yourself. If you have done the arrays part, this will be easier for you, because you have to use, in most cases you have to use the built-in methods. Yeah. Okay guys, so again, please, if you don't pause, do it in the other exercise, try to do it yourself first and then continue watching the video with the solution, because I would not be valuable for you if you just watch me how I type the code and you type it with me and just listen to me. Is not gonna make any sense for you. You're gonna think that you understand everything, but after a couple of days, if you occur this problem and if you try to approach it only by yourself, you won't be able to do so. So yeah guys, thank you very much, and let's see what the other problem is about. Hello everyone. So let's see one more problem, and it's a rather challenging one, not like the one before. So we have to read a list of integers in a range from 0 to 1000 and print them in ascending order along with their number of occurrences. So we have two different solutions. Let's see the first, the simple one, and we're gonna do it by ourselves with the simple one, but we also have another solution by sorting numbers. I'm just gonna show it to you. The difference between both of them is that here the first one uses more RAM memory, because we create a very big array here with the maximum. We get the max number of this array, and we create an array of size the maximum number plus 1, because again plus 1 because we start from 0, and we make that because each index inside the array represents the number inside the number from the input, and the value at each index, the elements represent the occurrences. I'm gonna show it to you right now. So let's just see what we have to do is we have to read from one line space separated numbers. We have to read them. So yeah, let's create a list. This list, right? Yeah. List integers. We're gonna create the direct integers. I'm gonna show you how to. I've shown you this before when we were using arrays, but we're gonna again see that how we can convert directly to list of integers, not list of strings, then for loop and parse each value from string to integer. We are using LINQ. So we have to read first from the console line. Then we have to split by a white space. Then we are using select. This is the LINQ. Select int.parse. What does that mean? Is it parses every value from the array. It parses it into integer, right? And then we have to convert this collection to a list, because initially it was an array. So what we need to do now, what we have right now is, let's see the inputs, just the primary input, 822 82237. We have 822 822 right? Same, right? Yeah. Okay, so right now we'll be having 8 2. Okay, so right now we are having a list of oops. Okay, so right now we have a list of some elements that we have inputted from the console line, and what we have to do is we have to print in an ascending order. It's an ascending order. We have to print each time how many the occurrences of each number inside this array, the occurrence of each element. So basically we have to print like 2, 1, 2, 3, 4. We have to print 2 4 times, and then 3 1 time, and so on. So without sorting, what we can do is we create an array of length the maximum number, because the index will represent the number itself, right? So we'll create here the maximum number is 8, right? And we'll create an array of size 9. Oops, sorry. We'll create an array of size 9. 1, 2, 3, 4, 5, 6, 7, 8, right? With indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So that's it. And each index will represent the number, right? So initially we'll have 0, and what we do is, as we know, in an array we have values by default. So the array is in predefined length of 9. We have we have all elements equal to 0, and we start iterating through this array. So what we do is, each time we get an element, we increment the value inside the array of this index. So here, we start from index 0, right? We get 8. So we say, okay, count array at index 8 plus plus. Here it becomes 1, right? Then 2. Here becomes 1. Then 2 again. This becomes 2. 8 again. This becomes 2. 2 again. This becomes 3. This becomes 4, right? I'm gonna write it here because 3. This becomes 1. And 7. Oh, this becomes 1, I'm sorry. And then we have all the occurrences in the array, and then what we have to do is just create a for cycle inside the array, start from 0 to the end. So from left to right, it means that we're gonna show it in an ascending order. If they want it in descending order, we can just start from right to left, right? And we print only if the value is bigger than 0, because if the value is 0, it means that there are no occurrences inside the list of elements that we have inputted initially. So let's do it. So we have the list from the console line, the list of elements. So right now we have an integer occurrence array, which is equal to new integer nums dot max. So we need to get the max value of, because indexes will represent the numbers themselves, right? So we need to get the max number, the maximum number is inside the list, and because index starts from 0, we need to add +1, because if the maximum number is 10 and our array is of length 10, the last index will be 9, and we need the last index to be 10 because the index will represent the number, right? So we have the occurrence array, and right now what we have to do is, so for, not for loop, maybe for each will be cleaner. So for each number in the nums list, go ahead in the occurrence array at index, the same index as the number, and increment it. Can we do it like that? Yes, we can do it like that. So for each value, go ahead and increment an occurrence array, right? After that, we have to create a for loop that will print those values, right? So we have to create a for loop inside the occurrence array, right? So occurrence array dot length, and we have an if statement. If occurrence array is bigger than 0, what? Oh, not print. Oh yeah, I'm too sleepy. So dot right line. So let's see how did they want to print it. So they want to print, initially they want to print the number and the occurrences, right? So they want to print the number, means that this is the index of the array. So we're gonna print I. So we're gonna print I plus, oops, yeah, okay, plus occurrence array from I. Should be it. So you can see it's very simple, and let's see what will happen if we run it. 23784112, right? 4112. It's easy peasy, right? So we have another solution which is more complicated, but here we use sorting. So what we do here is we only have, we don't create a new array to save the occurrences. What we do is we count. Initially what we do is we sort this array. We sort this array in an ascending order. Then we will be having all same values next to each other. We'll have 2, 2, 3, 3, 4, and so on, right? We start from position 0, and then we get the first number, and we need to have a counter, right? So we start from the first value, we have a counter, and we get the first value, save it here, and then while position plus count is smaller than the count, and while the current and the previous values are the same, increment the counter and increment the position, right? So, and then print the number plus the count. It's a bit, I mean, you have to write it yourself. It's a bit complicated, but don't worry, you can do it. You can do it that way. As I've told you, you have to figure out your own approach to each problem. I can't just tell you that's the way, you should do it that way, you should learn it by heart. No, this is not physics that you need to know a formula or you need to know something. Of course, you need to know how to declare a list. You need to know how to declare an array. This is part of the syntax of the language. This is like knowing how to write in English or knowing how to write in some other language. This is completely alright. But how to approach a problem, there is not a single formula. It's just you. You have to know how to approach. You have to think. You have to analyze what you need, what you have, what you need, what you have, what is your goal, and what you need to do. You have to figure out all the steps in meeting that goal. And I'm showing you right now some helper data structures that will help you to actually achieve your goal, right? Okay guys, so when it comes to our lab, this is our lab. You have a lot of exercises to do, but you have hints as well. And as you can see, you have the hints as you can see, this was the counting occurrence using array. Oh, you don't see it. This is quite strange. Okay. Okay, you see it right now. So counting concurrences using an array has a drawback, as I told you, because it depends on mapping numbers to array indexes. It will work well for input values in this range. That's why you can consider this solution as a viable. But if the range of the number is bigger, you may using occurrences by after sorting your list. This was actually the last exercise that we have done. You have another similar exercises that you have to practice yourself. Please do them now. If you have any questions, I'll be happy to help you. And yeah, please take this seriously and do your homework. Also, after you do the lab, we're gonna do the exercises because they're a bit more complex. But again, you can reuse your code from your lab, and if you do your job, it won't be like an issue for you to do the exercises. Okay, guys, thank you very much, and see you in the exercise session. Thank you. Okay, guys, it's time to see what we have learned today. So we understood what lists are, and some of the benefits of using lists, that lists hold a variable sequence of elements, but not with a predefined length like arrays. So we have also seen that under the scenes in the backstage, lists are actually arrays, but they are upgraded arrays. So with lists, we can perform some really easy. We can sort them. We can find elements in them. We can remove. We can insert at an index. There is a difference in how we create and allocate a list, but it's just a formal thing. It's a language connected thing. So, and also how do we access elements in the list is the same thing as accessing elements in an array, right? Printing arrays on the console is the same thing as how do we print arrays. Printing lists is the same thing as how we print arrays, right? So we can use string.join. This is the easiest way and the cleaner, yeah. So guys, please do your exercises. I'm gonna go through some of them, give you some hints how to approach them, but you need to figure out your approach yourself, the mindset. You already have the mindset if you have done the array. So yeah, please just be careful and test all your exercises in Judge. You need to have 100% to be sure that you cover all edge cases. Okay guys, thank you for now, and see you in the next lecture.